Well, hello, everyone. Please find a seat and let's get this thing started. All right. Well, first off, let me begin by saying this is my first time here at Devoxx Poland. I'm really happy to see so many people interested in all the topics that we have for you for these 3 days. So first off, a round of applause to you guys for being here. You guys are awesome. Thank you. This is why we do things. You know that you have this wristband. Stefan didn't say this in the morning keynote, but you should use your wristband to register yourself with the application, the Devoxx mobile app, and this is how you can vote. And it's thanks to the votes that we can, as speakers, we can make things better, and the organizers can also make things better. So please don't forget to vote. Now, after that PSA, I'm going to continue with the topic itself. So the topic of today is Java libraries you can't afford to miss. Now, I will suspect that some of you have heard of the libraries and the projects I'm going to mention. It's a little bit difficult for me to see the whole audience, but I'll ask you to raise hands, and this is how we can gauge how many people use a particular project or not. Okay, so my name is Andres Almiray. I come from Mexico, but I didn't travel all the way from Mexico to be with you guys. I actually work for a Swiss company called Canoe. We do lots of interesting stuff with technologies. Actually, many of the projects and the Java libraries that we see today, we make use of them at our daily work, and this is how we gather that experience and get knowledge that these things actually work in many cases. I'm also a Java champion, as you can tell by the jacket. I'm really like to work with the Groovy language, and I'm the leader of the Griffon framework. So any of you ever had the need or still care about writing desktop applications in the JVM, please give Griffon a try. So, okay, let's just get started. Now, it's 2016, and I believe pretty much everybody should be writing applications using dependency injection. So let's see some hands. Who is not using dependency injection in the projects? Oh. See, it's difficult, but actually I don't see any hands, so that's good. So the first project that I want to talk about is the reference implementation of the dependency injection JSR 330, which is known actually as JUice. So some of you might have seen JUice before, Google JUice, yeah? So half of the people. Now, what's interesting about Google JUice is that it used to be a lightweight library. It only delivers what is necessary to create objects to do dependency injection. Now, the fourth version that was released a few months ago actually includes another library that we're going to discuss today also. So you could say that it's not really lightweight in the sense of dependencies, but in terms in behavior, it's still pretty simple. This is basically what you do. You define classes or interfaces and bind those classes and interfaces, so pretty much types, to a particular implementation. In this case, I'm binding an engine, which is probably an interface. I'm binding that to another concrete class, the Fusion Power Engine. Hopefully, we'll get those engines in the near future. And what is interesting is that this class may or may not have any annotations on it, but we are telling the dependency injection container that we want this particular target to be annotated with a specific name. It's going to be the efficient engine. And then we also got another very old engine coal-powered, and that we had tagged as the poor engine. Now, once you have this, you have several types inside your dependency container, which will be this injector right there, the injector we created right there. So once you want to grab an instance out of that, there are many ways. So for example, you get a type, just supply a type, a regular class, and you'll get the mapping automatically. But because we need to type also the annotation, we need to add that particular tag or qualifier, as a matter of fact. We need to create a key. So many ways that you can query this. And once you have created an instance, what is interesting about this is that if this, by any chance, that specific implementation of engine requires additional dependencies, the container will supply them to you. There are many ways that you can define bindings. This is the easiest one. You give a source and a target. You can also have lazy initialization. Instead of giving a target, you define a provider, or in the case of other dependency injection containers, those things are called factories. You can have things in singleton scope or session scope if you're building a web app or any other kind of a scope that you build. So again, use is quite simple. It's really straightforward. And most of the things that it does is just supply dependency injection. So the next one is probably one that you have seen all over the place already. It's called the Spring Framework. It turns out that Spring is earlier than Juice. Juice came later. Now, of course, Spring is a whole ecosystem of projects. So who uses here Spring? Yeah, most than half of you. Perfect. But the interesting thing about this Spring Framework, I mean, just the core. I'm not talking about Spring Data or JPA or Booth or MVC. Those things come later. The core of the framework is not just dependency injection. It also has additional capabilities. For example, did you know that the standard message format class from the JDK is not thread safe? So when you create an instance of a particular message format, if you do not synchronize on it, you will very likely get in trouble when you're working with multiple threads. So what the Spring people did is create a facility that will do the right thing for you when you need to work with different messages and message formats and message sources. You also got validation and simple errors, and you got the easiest way to define beans on a JMX server is through a Spring core. Believe me, it's so that simple. The JDBC template is also very simple and trivial to use. And we also got testing and scheduling. So if you want to have something that is more than just a dependency container, and you need to deal with internationalization, validation, JMX, if you're not using a Spring Framework, I will suggest you to give it a try, just as a regular dependency. You don't need to buy into the additional Spring ecosystem projects for this to work. And of course, you will find many people on this conference talking about the different Spring-related projects, so I'm going to leave it like it is right now. So those are the two basic ones. Of course, there are other dependency injection providers, but these, I would say, are the most basic ones and the ones that you will encounter most of the times in several projects. So now let's turn a little bit about behavior. And let's do a quick polling. Who uses a particular login framework? Do you guys use login at all? Yeah, maybe? OK. Which particular framework do you use? Let's see, JavaUtil login. Just a few hands. Good. Don't use it. Bad. Apache Commons. I guess you use it as a transitive dependency if you didn't notice. What's the other one? Log4j. More hands. Perfect. Logback. JBoss logging. Just a few hands. So actually, what I want to talk today now is this one, SLF4j. Let's see hands for SLF4j. 30%. OK. So what is interesting about this logging framework is that first, it's faster than the other ones. OK, let's get this out of the way. There is no perfect Java logging framework. All of them are bad. But this one is the least worst of all of them. OK? Now, this being said, bless his heart. This being said, SLF4j can wrap around the other logging frameworks. So if you are consuming a dependency that relies on Commons logging, from Apache Commons logging, for example, many of the projects from Apache, HTTP client is one of them, or if you rely on older versions of Spring, they use either JavaUtil login or they use also Commons login. So it doesn't matter what you're doing, you can route all the different logging messages through the same pipeline, and that pipeline will be SLF4j. Now, another great thing that SLF4j has added in the latest releases is the capability of supporting variable arguments. So when you say log info and supply a string, here's one particular problem. The string that you are using for the login message may have, depending on your use cases, may be expensive to compute. And if the info level is disabled, you already spend time creating that instance that is going to be automatically discarded. So what you have to do is guard those login statements using if log level info or trace or debug is enabled, then do the actual info. So that's just verbosity. So the great thing about variable arguments is that you supply the method, then supply the formatted message and additional arguments. And it's now the implementation, the one that does the guard inside. So your login statements looks much better. I guess this is, for me, the deal breaker of using SLF4j over other logging frameworks. Variable arguments, and then you can route everything else through LSL4j. So please give this one a try. So when I mentioned JUice is now a little bit bigger than before, it's because it also now, the latest version, version 4, uses or depends on Google Guava. Who uses Guava here? Yeah, half of you. Perfect. Now, Guava, it's a project that gives you functional capabilities if you are working in JDK 6 and JDK 7. Of course, now we know that once we have Lambda expressions and default extension methods on JDK 8, perhaps half of the functionality provided by Guava is not needed anymore. We got predicates and consumer and so many other different functional interfaces. That's great. But another thing that Guava delivers are specialized collections that may be missing, perhaps, from the JDK. Do you need a map that can give you, that if you supply a key, of course, you get access to the value. But if you want to know which key is tied to a particular value, so you usually use two maps. But that's exactly BMap. It's just one collection providing the same behavior. Or, for example, multi-map. You have a key and multiple values assigned to that. The usual construct that we use is add a list as the value and manually handle the list. If it's empty, if it's not null, we need to create it. If you use multi-map, this is already handled for you. And if you need multiple keys associated with a single value, that's precisely what table is giving you. And you got many other additional methods working on these collections, on standard collections, and also we got caches and reflection and some additions to working with I/O and NIO. So definitely have a look at it, especially if you're already consuming JUice, you already got Guava on your class path. So why don't give it a try and see what's going on inside it? Next one, I would say, OK, HTTP. Anybody here still using HTTP client from Apache to create Apache client, HTTP clients? A few hands. Well, it's actually the most popular HTTP client that is out there. So you probably are consuming it as a transitive dependency. Now, the thing about OK HTTP is that it's a reimagination of how a very small and lightweight HTTP client should be. But it also supports HTTP2 already. So if you are already building HTTP2 servers and you need to consume them from Java, use OK HTTP. And as you can see, it's very straightforward to work with this, this class. So let's create a client and then issue a request, supply some parameters on it, then issue a call from that request. You get a response, and then process the response. The response has additional methods such as headers, when you want to inspect which headers are coming in. You can also set headers on the request. You can configure many things. You can have network interceptors that work such like filters. You can enhance request and response. It's actually very easy to do, and I really like this one. So if you need to create, again, HTTP clients from Java, please give OK HTTP a try. Really good. Now, the basis well, HTTP is the basis of many of the client-server applications we're writing right now. And you probably have heard in the last 2 years, perhaps, 2 to 3 years now, there's now a growing buzz on a new paradigm, reactive programming, right? Who here is familiar with RxJava? There was a talk about RxJava and Ratpack just an hour ago here. Perfect. So what RxJava allows you to do is this idea of reactive programming. Instead of asking the producer to give the data, what you do is you set up a pipeline of instructions that are somehow hooked into the producer. So when the time comes that the producer says, oh, here's new data, it goes through the pipeline up the way to the consumer. Now, this is great because the consumer now can just simply lay back and wait until the producer is ready to supply the data. So in this particular example, what we're seeing is that this is some class that sits behind the GitHub API, and we're going to see how it's done in just a moment. So think about this. There is the GitHub REST API, where you can issue a REST call and then get some JSON response out of that. Somehow, we're mapping that JSON response into objects, and we want to wrap each object as part of this pipeline of streamable results. The pipeline is the observable class you see there. And the additional operations that we're doing on the observable will decorate it. For example, the take operation we see there. If there happens to be a number when we say there may be 100 repositories on the UI, on the URL that we're going to query, but I just want the first 10 ones. So I supply 10 as the limit, and then it doesn't matter how many calls this thing could do. The moment that it reaches 10 repositories, the whole pipeline stops. The next things we do is that when we start the pipeline, we change a particular state in a model class, and when the pipeline terminates, we change back that state. So how can we finish this? Maybe we process all the elements. Or maybe there was a network error, some error in between, so there was an exception. In the case of terminate, it doesn't matter how you finish. It was a good finish or the bad finish, it will always happen. And on the subscription, this is when we say, once you have an object, once the producer says, here's the data, as a consumer, or in this case, the subscriber, this is how I'm going to work with that particular data. So in this case, just adding to another list, and this perhaps is going to be displayed on a UI. Perfect. OK. So here's the other thing. The GitHub API that I was talking about is actually a REST-based API. So how would you create a REST API or some kind of Java client in order to consume the GitHub API? Well, probably you use HTTP client, but now you probably should use OK HTTP. But I have another one for you. Better yet, use Retrofit. Retrofit is another project from Square. They get the same makers of OK HTTP. And this is exactly what it does. What you do is you supply an interface and annotate it with your particular REST metadata, with this is the URL, and this is the get parameter or the post parameter, anything that is needed, right? And then you create some instance of type retrofit, supply the endpoint, use some converter factor. In this case, whatever object is coming from the other side, I'm going to map it using JSON data, using Jackson as my provider. That's why this thing is there. And then just build it. And finally, you create a proxy class based on that interface. So the magic behind the scenes is that this proxy will rely on OK HTTP, do all the wiring for you, so that at the end, you as a consumer only have to deal with this API. So it's much easier to say invoke repositories with a single string and then just get some object on which we can get the response and then read all the elements. In this case, that object will always return a list of already converted JSON map data to repository objects. So it does much of the heavy lifting for you already. So that's pretty cool. OK. But this kind of client is still a client where we are asking data from the producer. We are pulling data. But on the previous slide, we say that we can build a subscriber or a client that sits back and waits to be notified of data. Would it be possible to combine RxJava, the observable way, with Retrofit? Well, it turns out that you can. And here's how. There is an additional dependency or an additional jar that you can find out there on the web. It's called Retrofit RxJava. And this will allow you to return observables directly from Retrofit. So notice the difference. The previous one says it's just a call around a list of repositories, whereas the next one is actually an observable that wraps the response. Now, what's going to happen in here is that now you have to add an additional factory on how Retrofit should marshal the data. And when you call this method, now you get back an observable. And what can you do in observable? You can register subscribers, you can decorate it, you can do take, you can do drop, and most importantly, if you are consuming multiple endpoints, you can combine observables. Anybody here uses Scala should be very familiar with optional and flat map, right? So in observables, you can almost do the same thing. There is a flat map method. So if you have multiple observables, you can combine them in a single one using just flat map, or you can also use concatenate. As a matter of fact, there are many operations that can be invoked on an observable. You can zip, you can do a T, there are so many things that you can do. So this will allow you to build REST clients effortlessly just by defining an interface, and also turn them into reactive clients. It's quite simple, but there will be a problem with testing. But don't worry, I also have an option for you how we can properly test this kind of stuff, because now we're talking about doing many things in many different threads, right? Okay, next one, JDefi. So, RxJava gives you the capability to consume many things whenever they happen, but JDefi has the other side of the coin. It gives you the capability to invoke a task or some behavior in a background thread, and whenever that is ready, you get a notification. So people that do JavaScript these days, they know promises, right? So this is basically what JDefi is giving you to you. It's giving you a Java-based promise. And what is great about a promise is that once it finishes, you can chain that into another promise and another one, and you can register a fail event handler or a done event handler. So this example that we're seeing here is the same that we saw earlier in the observable way, but now is done in the defer way. The difference starts here that while the observable way will allow us to simply consume whenever data is ready, in this one, we are doing everything in one go. And once that is ready, we are able to process. JDefi gives us another capability, which is intermediate results. So that's why we have this progress method right there. So this code is built in such a way that when and actually it's using also Retrofit behind the scenes. So when there's the REST call and you got a map object, a repository, it will figure out, do I have reached the limit? Because we're passing the limit somewhere there as a parameter. If I don't have reached the limit yet, then the object inside that promise has a method called publish. And this is how we're going to move the data upward into the caller. In this case, is right here. And this is how we process. Anybody here done work with Swing and Swing Worker? Yes? No? Basically, it's the same idea, but it's not attached to UIs. And now, for some reason, this project, JDefi, is very popular in the Android community, because when you're working with UIs, the golden rule is that any processing that is not UI bound has to happen in a thread that is not the UI thread. So you do a promise that is a background process. And once you're done, that will be either is fail or always or done. Then you come back into the UI and update whatever you need to do. Or maybe some intermediate result like here. So actually, this whole application is a JavaFX application that uses all these different projects in order to deliver what it is. And in case you would like to know more about JDefi, we have the author right here in the audience, Ray. Say hello, Ray. Yay. Pretty good. An amazing project. Next one, event buses. Event buses, there are many reasons why it was just a good idea to use an event bus, but basically have different components that do not know each other, but somehow they need to be communicated, right? Guava has an event bus, but turns out that this project, Ambassador, has a much higher throughput and is more efficient than the one supplied by Guava. It's also a little bit easier to use. Basically, what you have to do is you define any class. It doesn't have to implement a specific interface or subclass for a particular type. Just any type you want, any object, create an instance of that class, Ambassador, and then you can, where is the registration? Whoa, I missed the subscription. So you actually, on the event bus, somewhere I need to call subscribe. Here I'm publishing an event, but in order for this handler to be called, this whole instance, this event handler, has to be subscribed to this event bus, and this error in my slides. Anyway, you subscribe and you unsubscribe from it. And whenever you're ready, you publish whatever you want to do. In this case, this new instance event has to be a subclass of the base type that you define it right there. You can publish synchronously or send, or you can publish asynchronously or post. You can also filter the events here. There's an annotation called filter. If you want to have subclasses of the particular event type, or does it fit in certain particular range, or does the event have some particular characteristics that you want to handle or not, without doing that in the handler itself. All right. I guess hopefully so far so good. Now, okay, before I switch bytecode AST, you see this code here? I'm particularly fond on creating builders for POJOs. Because in that way I can make my POJOs be immutable, but the builders are the ones that contain the mutable data. Now, it's definitely a pain to write those builders by hand. Fortunately, there is a project called Lombok. Who uses Lombok here? Okay, 20% of the people. So Lombok is basically a macro. It's a bytecode generation. It tags into the annotation processing tool, which is not what it was designed for, but it's working. So what is happening here is, for this particular person class, we annotated with the data annotation, and this will give us getters and setters for free. We will also add all the required arguments in a particular constructor. So we will have at least one constructor that takes two arguments, name and last name, because we define this as final. We will also give us an equals and hash code implementation that follows the effective Java conventions. It also will give us a toString method. And finally, we annotate this static method. There are many ways that you can do this, but I prefer this one. I annotate a static method, any name, with builder, and then you supply the arguments. What's interesting about that annotation, which is coming from JSR 305, Lombok has its own not null annotation, which we'll recognize, of course, but it will also recognize the non-null annotations from JSR 305, and I believe it will also recognize the non-null and nullable annotations from IntelliJ IDEA. What is going to happen here? That when you call the builder method, and if you do not supply a value that is annotated on non-null, you will get an error automatically. So it's a good thing to annotate these preconditions with annotations. And there's the constructor I was talking about that is automatically generated by the data annotation. So once you do that, you can also do stuff like that. Actually, this is the application event that we're looking at on the previous slide. Extends from that class. So I want to have the equals and hash code include whatever this superclass has. The same goes with the toString. This is annotated with non-null. It's final. data, boom. You get getters, setters, everything. And it just works. I just have to say that of all the different IDEs that you can use to work with Lombok, sadly, Eclipse is the one that it works, but it's a little bit of pain to configure just because how APT is configured with Eclipse. The other ones don't have much problem because everything is available in the class path. Just so you know, if you try to use this with Eclipse and Lombok sometimes doesn't work, there's an additional manual step that you have to follow. Actually, I believe there's a Lombok installer that will help you configure Lombok for your system. But that's basically it. And it's really good. I've been using this with customers that I cannot tell you the name, but it's a quite a big bank in Austria that relies on this. So if these people are using annotations and bytecode generation like that, pretty sure you guys can also do it the same thing. But if bytecode generation is not what you would like to do, you would like to have something that is more closer to the runtime, then we have ByBody. ByBody, for those of you that are familiar with Ruby or Groovy, gives you almost the capabilities of runtime metaprogramming. Or, as we did it in the past with aspect-oriented programming, that you can add or modify behavior of a particular class that has already been loaded by the class loader. So this particular example of ByBody, we have an existing class. We can define classes on the fly. This is great for people that need to work around problems with proxies. But for this particular example, we got a class foo that we're going to enhance. So the bytecode is already loaded, but what we're going to do is intercept a method that is named foo, like that one, and it takes one argument, that one, and instead of returning null, what we're going to say is we're going to return a fixed value 3. So we load that enhanced class with our current custom class loader, and there we got that dynamic foo. So from this instance now, if I call the foo method, passing one argument, I will get now the result 3 as a string instead of a null. So this is pretty much aspect-oriented programming in a different way. I would say it's much easier. The library is actively maintained, and it has pretty good quality. So speaking about quality, how do we know things have quality? How do we know things are compliant to a particular specification? We have to test, all right? Is anybody here not doing tests? Yeah, good. Thank you. Well, I guess most of you use JUnit. Who uses testng? Just a few hands. Good. Well, if you're using JUnit, it's my personal experience. I've seen many people just use plain JUnit, and off you go. It's very easy to get started. But just like in production code, we had to take care of duplications. We want our test to be as good as our production code. So we had to reduce those duplications, and we had to keep our code dry. So one of the ways that we can keep our code dry is by making our tests parameterizable. I know that JUnit 4 includes some support for parameterization of your test case. The problem is that you can only parameterize a single method per test case. So if you have 5 methods that need to be parameterized, you end up with 5 different classes. That's a little bit of a waste. So the good thing is that we have a project that is actually from Poland, great, from Poland to the world, called JUnit params. And JUnit params allows you to parameterize any methods in a single test case. You can supply it in this way, just using an array of strings, or you can also supply a test method. And the method must return an object array of all the different values. So 2 things you need to do. First, use a custom runner, the JUnit's param runner. And secondly, annotate your test method with parameters, supply all the data that is needed, and also define particular arguments that the test method will take. And notice, well, in this case, it's also using a string, but it will do simple type conversion for you. If this were to be a number, and this is set to as an integer, or a primitive integer even, then that value will be automatically converted for you. So this makes writing tests much easier. Another thing that we do when doing testing is that sometimes we need to have our test under class run in isolation from its dependencies. This is where mocking and stubbing comes in. And out of the many different options that you have out there, I would say that Yukito is the one that supplies the best API for you to get started. So here's another test case. It's also parameterized with using JUnit params. And this method says, well, I'm creating some instances out there, and this particular service is going to be my mock. This is my collaborator. Then I define expectations using a Java-based DSL. When this method, when the method say hello with that particular input is called, and that input is calling from the arguments, then return that particular output. So my mocking is very simple. Then execute the code, finally validate that we got the right result, and also validate that the mock was called only once. We can match the cardinality if it was called once, twice, or as many, or at least. There are so many different ways. And if it was actually called with that particular value. If it wasn't the case, then our test case will fail. So we covered JUnit, we covered Yukito, and if you're using use, it's very likely that you want to use these things together, right? But I have one more thing to show you. This thing called Yukito. Yukito is JUnit, Yukito, and use rolled into one. So what is going to do here? What's going to happen is that you can define modules just like in use, but in this case, what we're doing is we expect the sample service to somehow be supplied by the test case. Now, this sample service could be a real bound instance like you do in regular use, or it could be something that is unbound. This is the case. When it's unbound, Yukito will automatically create the mock for you. Notice that we are not doing a mock somewhere else. And this is just a regular default method. So Yukito is smart enough to figure out, oh, you're asking for a sample service. I didn't find a binding for it. So I'm going to automatically create a mock for you, and here it is. So we can apply the same code that we saw earlier, well, almost, because this one is not parameterized. And then the color here is almost the same as we saw before. We can also do the verifications on the mock automatically. So this simplifies your code explicitly when you have much more dependencies and you have to rely somehow in dependency injection. So Yukito is pretty good. We also got, well, so far we have covered Java-based approaches. Now, you remember that when I started the talk earlier, I said that I love the Groovy. Well, there is another great Groovy-based project, which is pretty much a testing DSL, but can be used to test Java code. So all the code that we're using so far, testing and production, is Java. What I'm going to show now is Spock. Spock is this interesting testing DSL that allows you to have pretty much the same behavior as before, but writing less code. Now, for those of you that are new to Groovy, let me tell you that it's so easy to get started. Just grab your Java source file, rename it to .groovy, and compile it to the Groovy compiler. 98% of the times is going to work because the Groovy syntax is a superset of the Java syntax. So, besides knowing a few things about these libraries today, I can tell you with fair confidence, you guys now know another language. You guys are now also Groovy developers. It's just as easy as that. Trust me. Anyway, what we have here is a method. The method name looks weird because it's a string, but hey, it's Groovy. With some placeholders there, input and output. We'll see what's going to happen in that in a moment. And then we got some blocks, given, when, then, and where. In the given block, we initialize our class under test, the controller. Well, we also mock the service using Groovy syntax to say whenever that input comes in, that stimuli comes in, we want that output to happen. When that stimuli actually happens, that is to say hello, then we expect this to be true. Notice that in the then block, we don't have any assertions. That is because Spock knows that if you are inside the then block, everything, every expression you put there is an implicit assertion. And finally, we got something that looks as another block called where, when we define those variables, input and output, and we supply values. Actually, this is a collection literal for lists. So this is an empty string with test, and another test string, and another thing. So this input will match this output, and that input will match the other output. This method will be called twice because we got two values. And finally, the unroll annotation is the one that will actually generate the final name of the method. So this value will be put there, will be substituted. So this is a placeholder, and that value will also be put there when we run it the second time. So the actual method that you see generated, and in the IDE also works, will be invoke say hello with empty string, results in howdy, stranger. If this looks weird to you, don't worry. The JVM supports any kind of characters as a method or as a method name. It's Java, the language, that restricts the number or the type of characters that can be used on a method. So Groovy gives you back the capability to be very expressive by defining any kind of method name. I said something about multi-threading and testing, RxJava and JDefi. How can we test multi-threading? It's actually hard. And many people, trust me, I did it also. What we do, slap in a thread slip somewhere to make sure that our code is waiting to the right time. And sometimes we have to play around if it's 5 milliseconds or also 5,000 milliseconds, something else, right? So let me tell you about IWaitTill. IWaitTill is a much better approach to dealing with multiple threads and testing. So here's the same test as before in Java. It's parameterized. Now we are creating our class under test in a different way, and then invoke that stimulus. But I know for a fact that this application, being an integration test, that's the reason why I'm creating things in a different way, is actually running on the real application. So that means if this is an UI-based application, happens to be a JavaFX application, the result will be executed in a thread that is a background thread. And this background thread is not the same as the testing thread. So when I invoke this action, there's something going on concurrently in a different thread, right? So I need to wait for that operation to finish. How can I wait? I could use thread sleep, right? But then I have to balance it if it's going well or not, or depending on the platform. What I can do is call this static method from IWaitTill and do until. And notice that is JDK 8 friendly. I'm using a lambda here. You can wait until this particular object results on a non-null value. This is just a regular hamcrest matcher. I would expect everybody to be familiar with hamcrest because you said you use JUnit. So I know that this behavior, whenever it's finished, will change the value of that object. So it could do many things, but the last thing it has to do is change that value. So now I can wait, perhaps forever, or I can give it a timeout actually as an additional argument. Wait until 10 seconds, but also this condition. If after 10 seconds that condition has not been satisfied, the test will fail automatically. So your test will not be running forever. That's also good. Now, the final one that I want to show is rest assured. This is mostly for people that are writing web applications and have some kind of server, or maybe they have a REST API behind a service, and you want to test it out. The easiest way for you, instead of just creating a client and do things manually, is to use this project called Rest Assured, which allows you to basically point it to a particular URL and then call assertions of that one. So you can assert on the headers, on the response, on the body. It will automatically translate data from JSON and XML, and you can transverse that using JSON path and XML path. And here's another option that, given some input parameters, then you make a post to a particular URL, then you expect certain body to contain some value. This OK, it doesn't matter if the response is JSON or XML, because you can use JSON pad and XML pad inside that thing. So this is great. It will definitely simplify your tests. Finally, some honorary mentions, because we're almost running out of time. But there are a few other technologies that perhaps are a bit more focused into certain areas. First, there is OK.io, which is additions to Java I/O and NIO, as a matter of fact. It's actually the one that is powering OK HTTP and Retrofit by association. We also got a very, very lightning fast connection pool called Hikari CP. If you use Apache connection pool or C3PO or something like that, let me tell you, your application is really slow. If you have problems with that, switch to Hikari connection pool and your application will be blazingly fast. The next one is gRPC. If you want to connect different clients and servers, I would suggest you to use gRPC because it not just works with Java, but Go and other languages. Even I'm not so sure it works with, it has C# and C++, Python. So you can connect clients that are written in one language talking to servers written in the other language. And you have a very basic IDL in the middle. It's Google Protocol Buffers, which is supported by all languages. And it's pretty fast. And they claim it's even faster than plain REST. So if you need to do this, give it a try. If you want to, or you need to stick with just the JVM, the fastest serialization mechanism that exists out there is called Cryo. And there is also an ARAMI alternative to Java ARAMI using Cryo, which is called CryoNet, that relies on Cryo and the Neti project. And finally, if you are building a client, but you don't have a real server, or you don't want to use a server to test out your client, what you can do is use mock server. A mock server allows you to set up expectations on the base data that can be returned. So now you can test out your retrofit RxJava client with using a fake server where you can set up all the possible expectations, all the possible outcome without having to launch a real server. This was what you would do using a functional test or some kind of black box testing. So it's been quite a whirlwind tour of different technologies. I believe the count is close to 22 or 23. I hope that this talk has been good enough for you, that has given you some hints about technologies that are good to try. And my personal experience, I have used most of this already in production. Some of them are already in current prototypes. And what we have seen so far is that we are very productive with these things, especially the testing solutions. So I know that you guys have a choice. Thank you for being here. Thank you for being awesome. Hope that you continue enjoying Devoxx Poland. If you have any questions, I guess that we still have some seconds. If not, well, I'll be here for the rest of the day. Please feel free to grab me around on the halls. So keep enjoying Devoxx Poland. Thank you.